Remember me, Ariana? We're buddies. We were in the elevator that one time. Anyway, I'm doing my presentation on tryptophan. So first I want to start off with a little survey, kind of. How many people have ever heard a rumor, besides 10 minutes ago or whatever, that turkey makes you tired?
In the same presentation? Wouldn't that be minus points right away?
I know, right? Yeah, no. Right? So a bunch of people have heard that. There's this like urban legend, basically, that turkey makes you tired. And so a lot of times on Thanksgiving, people are like, oh, I'm so tired after Thanksgiving meal, you know, whatever. Are you recording it?
Yeah.
Hi. Do I look okay? Is this my good side?
Minus 10 points.
Minus 10 points, no. I broke the third wall. It's okay. Let's see. Right. So I was thinking about that recently, and I'm like, I wonder if there's chemistry behind it. So my presentation is there a chemical in turkey that makes you sleepy? So that's what we're going to talk about. So when I was doing my research, I found out that tryptophan is kind of the culprit. Everyone's pointing their fingers at tryptophan and saying, yeah, because there's tryptophan in turkey, so that's why it makes you tired. So let's talk a little bit about what tryptophan is. So basically, tryptophan is in turkey, but it's in a lot of foods. Like it's in, hello. Tryptophan is in like eggs and beans and meat. What do all those foods have in common? Protein. Tryptophan is in foods that have a lot of protein in it because tryptophan is like one of the components of protein. So lots of things have tryptophan in it. And tryptophan is used in our bodies to make other things. So basically the way that like kind of digestion and all that stuff works is that you eat a piece of food, right? So let's say I have some food, delicious. And I'm going to take that food and I'm going to put it in my mouth and I'm going to chew it. And what I'm doing is I'm pretty much breaking the pieces of food and I'm making them smaller and smaller and smaller, right? And then when it gets to your stomach, it gets broken down even more. And then we take the little broken down pieces and we use those as ingredients to make hair, skin, whatever we eat, blood, whatever. So it's kind of like recycling. So it's like taking like this, right? And then, or like, you know how you can take gold and melt it down and make a new thing or whatever? So it's like that. Like you take the thing and then you break it apart and you make it what you want it to be. And that's exactly what we do all the time when we're eating. Does that make sense? So tryptophan is one of the little ingredients that are going to be in the food. And so when our body digests it and breaks it down, then we get the tryptophan that we can use to make a whole bunch of different things in our body. So this is the chemical structure of tryptophan. And I want to point out some of the unusual things about the structure. In this class, there's a few different types of structures that we did. Name some of them. Lewis structure. Yeah, what else? Skeletal structure, right? So down here, it looks like a skeletal structure because you don't see the actual atom. What atom is that? Carbon, double bonded to another carbon, and so on, right? But then up here, what kind of skeletal, what kind of not skeletal? Lewis structure, right? So it's weird because sometimes when you look up chemical structures, they're like weird hybrids between Lewis structures and skeletal structures. So I just want you to be aware of that. And then sometimes they even have, like, what does this kind of look like? A molecular formula. It's weird. They just didn't want to show the two H's. They just said that there were two H's. So sometimes you'll see that. And it's important to make sure that when you look at it, you kind of understand what you're looking at. So anyway, this is the chemical structure of tryptophan, and I'll talk you through that a little bit in a minute. So basically, tryptophan is referred to as this thing called an amino acid. It's the category of molecule it is. Just like you can have dogs with different breeds, and you can have like poodles, and all poodles have like these main things in common. This is an amino acid. It all has some main things in common. I just realized this is kind of like cut off. Go over this. Okay. So let me explain how all amino acids work. All amino acids have this basic structure where you got two carbons. One of the carbons has a double bond O and an OH, and the other carbon has an H and a nitrogen with H's on it. So there's a carbon with the O's and the carbon with the nitrogen. And then this carbon has some other pieces, other atoms kind of coming off of it. But all amino acids have this part, and it's what's here that's different that makes it one amino acid to the next. There's 20 different things that can go here, so there's 20 different kinds of amino acids. Right, okay, so that's what amino acids look like. So now if we look at the structure again, we can see that it's an amino acid. So here's that carbon with the two O's on it, and here's the carbon with the nitrogen, and then this is the rest of the molecule that makes it specifically a tryptophan and not a different amino acid. So what are amino acids used for? Okay, well, an amino acid, so like I said, amino acids are kind of like this, where you have the carbons with one has the double bond to O, and then it has the OH, and then it has the H here, and then a nitrogen group. the rest of the molecule. So amino acids are these tiny little things. And what happens is, I'm going to symbolize it by this, is that in this molecule, there's actually, well, what do you think? Is it polar, non-polar? There's parts of it that are polar, right? Because like the O's are going to kind of pull the electrons here, the N's might be pulled there. So in the molecule, you have polar parts of it. What happens is amino acids connect with each other, like pearls on a pearl necklace. They're all kind of connected together. So you have one amino acid and another amino acid, another. And you have like, I don't know, millions of them or something. They're all kind of connected. And there's little regions where they're polar. And when they're polar, that means they'll attract to themselves, right? So what happens is you have this gigantic chain of amino acids, and because they have these little polar parts on them, what do you think is going to happen to the structure of the molecule if they're kind of attracted? Yeah, they kind of like combine and they attract. Imagine if your pearl necklace had little magnets on parts of the pearls, and then you put that pearl necklace in your pocket. When you picked it up, it would be all kind of attracted in together and clustered up, right?
Are those called peptide bonds?
Actually, these ones are the peptide bonds, right? Didn't you say your girlfriend was telling you about that? Yeah. These are called the peptide bonds. It's the connection between the different amino acids. So the peptide bonds would be like the link that connects the pearls in the pearl necklace. So anyway, right, so amino acids combine, and this big new molecule is called a protein, and the protein ends up kind of clustering in because they're all attracted. So you get this like gigantic molecule that's a protein, and then that's what our hair is made out of and our skin is made out of and stuff like that. So amino acids are like little bricks, and then they connect to make a brick wall until you finally get a brick house or whatever. So yeah, let's see where we're at. Okay, so amino acids are used to make the proteins, and the proteins are gigantic molecule chemicals that make lots of things in our body. And there's 20 different types of amino acids, almost like there's 26 different letters, and they can combine and form different things. So there's 20 different amino acids that make all sorts of different proteins that we need. All right, so tryptophan is one of these amino acids. So it's like maybe that's a tryptophan or something. And our bodies, some of the amino acids our bodies naturally make, but a lot of them we can't. We have to eat foods that have it to get it. Tryptophan is one of the ones that we actually have to eat something that has tryptophan in it to get the tryptophan. So it's essential to our diet, and so it's referred to as not just an amino acid, but it's an essential amino acid. I think there's like 8 essential amino acids or something.
Wait, can I like ask a question?
Sure.
So if you like eat meat that has protein, right? Like how many different amino acids are in that?
Probably, I don't know, maybe like 8 of them, maybe 20 of them. Probably depends on the meat too. Okay, so how does this relate to tiredness? You're like, I don't know, but I'm definitely feeling tired. Hopefully not. Well, what I found out was that I saw a scientific study. It was really complicated, but basically it said that tryptophan makes this molecule called serotonin. I want to explain, like, this looks kind of confusing. It says tryptophan is a precursor. What does precursor mean?
So it's before?
Like the starting part. For the synthesis of serotonin. Synthesis is a fancy chemistry word to mean, like, making of. Like, you could say, oh, I'm going to synthesize a cake for your birthday, but you wouldn't say that because it sounds weird, but it's like the same idea. It's like when you make it. So tryptophan is the beginning when you make serotonin. It's like the ingredients. Fancy way of saying it's the ingredients. And so this is the chemical structure of tryptophan. And this one actually looks different than the structure from before. Why? That too. I was thinking more just because it's all skeletal structure this time. Before it was like a hybrid between all like skeletal structure and other things. But let me walk you through how it's still a tryptophan. This part is that carbon that had the O's on it. This part is the carbon that had the nitrogen. And then this is like the rest of the molecule. Again, what does it mean when it's a little darker like that?
Like coming after.
It's 3D. It's just coming out into the page. It's still a bond though. Anyway, so here we have our tryptophan. And what happens is it morphs a little bit and becomes serotonin. So first, it goes from this to this. What changed from here to here?
It got a OH.
Right, this is new. What is it called when you add an OH or an O? Oxidation. So in our bodies, lots of things can happen to the tryptophan, right? If we eat meat and it's made out of this big protein, and then we chew it, and then our stomachs like break it down even more. What is in our stomach that breaks it down?
Acid.
The acid, right? Because remember we talked about how if you have like an acid which is just shooting out protons all over, those protons are going to start ripping out electrons from molecules, and that's why these bonds start breaking. So this proton from our stomach acid is like, ooh, electrons over here, and it like breaks that, and it breaks that. And then you basically have the loose amino acids that reform to make hair proteins and other different proteins. All right, so yeah, so we have the oxidation, turns into this thing. And then from here, it does this. What's different from here to here? It lost this piece right here. It's not there anymore. Losing oxygens, what's that one called? Reduction. So basically, the tryptophan that's now separated from the rest goes off and may be oxidized and then reduced, and if it is in this specific way, it'll become serotonin. What do you think of when you hear serotonin? Has anybody ever heard of that before? What is serotonin about?
Chemical in the brain that makes you like emotional.
They're like receptors or something, right?
It's a chemical in the brain that makes you happy. So it's something that they say like when you're happy, you release serotonin. So for example, me, when I teach, I think my brain like starts releasing lots and lots of serotonin because teaching makes me really happy. If you haven't already noticed, I like get really excited when I teach. So when there's like a signal that makes you happy, it like releases serotonin, and it kind of like has something to do with making your brain recognize happiness. So basically, you eat turkey, you get tryptophan, and that may turn into serotonin. It might make you kind of calm and happy and stuff. So serotonin can also turn into this other molecule. It's another kind of chemical reaction I'm not going to go through, but it can turn into this thing called melatonin. Where have you guys heard about melatonin before? Not melanin, but melatonin. It's similar. It has something to do with sleepiness, and they have melatonin supplements that you take when you're jet lagged. Basically, what happens is our bodies are on these natural cycles, just like, of course, like women are on certain cycles, right? Well, everybody's on a sleep cycle. You get tired every 24 hours or so. That's why, like, every night at 11 or every night at 1 or whatever, you get kind of tired because your body is like in this cycle. And the way that the cycles are controlled are by different chemicals that are released in certain spurts. And melatonin is usually released in our brains at night, and it makes our brains realize that it's nighttime. So that's why sometimes if you go out of town in a different country or somewhere where there's a different time zone, and it's like you're 2 hours off, but you know it, but you're still tired at the wrong time, it's because your brain is still releasing on the same cycle. And so you can actually take melatonin pills, and it'll train your brain to be tired at a certain time. So if you ever have sleep problems, sometimes people recommend that you take melatonin. It doesn't work like, oh, I need to go to sleep, I'll take a melatonin. It's something that you have to take constantly because you're just retraining the cycle. Anyway, so when you take tryptophan from turkey, it turns into serotonin, turns into melatonin, and so it's telling your brain it's nighttime, it's time to go to bed. So theoretically, we should be getting really tired when we eat tryptophan or anything with proteins in it because we're making all this stuff that's going to make us think it's nighttime. But there's actually not enough tryptophan. And what I did was I found a study where they actually compared how much tryptophan is in different foods. And from the study, we can see that eggs have 4 times as much as turkey. When do we eat eggs? In the morning.
Dried egg white.
Yeah, I know, right? Weird, right? Dried. Who eats fried egg? Yeah. It's from the survey. Blame Joan Holden. Anyway. So clearly, if a gram is not going to get you tired, I don't think this is going to get you tired. So it's not the tryptophan that's making you tired during Thanksgiving or when you eat a lot. I have some other theories. I was thinking that it could be, well, here I wrote that it could be like, alcohol or carbohydrates that make you tired. But another theory that I came up with, and this is, I don't know if this is true, but my guess is maybe when we eat, our bodies undergo a lot of exothermic reactions. What's exothermic again? When you release energy. And so possibly like to break all that food down and all that stuff, like maybe it's exothermic. And so since we're giving off our energy, maybe we get tired after we eat. So if you eat a lot, maybe that makes you sleepy. So that's just a theory that I have. I don't know. But in conclusion, tryptophan is an amino acid, right? What does that mean again?
It's a protein.
It's little building blocks that make a protein. It has like a special structure to it. It's in lots of different foods. And it makes a bunch of different, it turns into other things in our bodies, some of which can make us tired, but it's just there's not enough of us to actually make us tired. How this relates to the professional world, I guess that if someone tries to give you the excuse, oh, I just ate turkey, so don't mind me if I get really sleepy, you'll know that they're just lying. So for all of you that are kind of like falling asleep right now, I know it's not because of the turkey. It's as much turkey as you want. It's not going to make you tired.
Melatonin.
Yes, melatonin. All right, and that's it. How was that?